Hi again, this is the third and final part of our mini course on building AI agents and RAG systems using Directual. If you haven't watched the first two videos, go check them out. We already covered the basics, what LLMs are, why you need RAG, and how to build an AI assistant that can work with your own data. But now it's time for the advanced level. We look at the things that separate basic LLM integrations from smart, reliable, production-grade AI agents. In this video, what Anthropic says about building effective agents, what structured output is and how you should use it, how to make LLMs think out loud with chain of thought, how to chunk large documents for vector search, how to catch hallucinations using logprobs, and finally, how to run an LLM locally on your own machine. Let's go. Let's start with some design thinking. Anthropic, the team behind Claude, recently published a great article, Building Effective Agents. It's about how to design AI systems that actually work in real-world products. We'll link it in the description, but here are some key takeaways. First, context is everything. An agent isn't a mind reader, it only knows what you give it. If you want smart behavior, you need to provide a good prompt, a clear structure, and some dialogue history or system instructions. An agent is not just one prompt, it's a sequence. Anthropic suggests thinking of agents as processes, where the LLM makes decisions, stores intermediate results, and passes them between steps. You can store these as objects or context variables and reuse them in later prompts. State matters. Example: the agent makes a request, gets a response, passes it to the next step. That is a state. It should be handled deliberately, otherwise your assistant becomes a forgetful chatbot with no memory. Don't be afraid to use multiple prompts. A prompt is just an instruction, but a real agent is an architecture. You might have one prompt to analyze the user input, another to decide what action to take, a sort of a router, another to generate the response, and maybe even a fourth one to review and improve the answer. This is the key idea. LLM is not the product, it's a building block. To build a smart assistant, you need to design a system, not just stuff everything into a giant prompt, and that's where Directual comes in. A platform that can orchestrate the whole thing. Got it? Cool. Let's move to something practical. When you first start using LLMs, you're usually happy if they just generate nice text. But that gets old fast, especially if your assistant needs to return a list of tasks, extract fields from a document, output proper JSON, or trigger something in an API. That's where structured output, or SO, comes in, a technique I really love. What is it? It's when you ask the model to return the result in a strict predefined format. JSON, XML, Markdown, a table, a list, anything that's machine readable and predictable. Why use it? To parse the output cleanly without regex hacks, to validate structure, all fields present, to use it in APIs or automation scenarios, to avoid situations like, well, I thought you meant this. Let's go back to our movie assistant example from part 1. We might write a system prompt like, you are a movie assistant, the user enters what kind of movie they want to watch, you return a strict JSON object with the following fields. Then we include the format in the prompt itself, and the model will usually respond with the well-formed JSON. But not always. Sometimes it forgets a quote, sometimes it adds a comment, sometimes it writes half an essay before the JSON. So what do we do? Be very clear in your instructions. Include an explicit format example in the prompt. Use chain of thought, we'll cover that in a sec. And if needed, validate the output in your scenario logic. If the structure is wrong, you can send the model a corrective message like, that wasn't valid JSON, try again. Let me show you how structured output works in the Directual scenario. We use the HTTP request tab or the custom request tab from the ChatGPT plugin to send the entire JSON request and receive the full response from the LLM. There are two approaches to structured output: response format, a simpler one where the schema is defined in the prompt, and function calling, a stricter one that consumes more tokens but guarantees the response structure. Let's take a look at both. Example, we add response format with the type JSON object. In the prompt, we list the properties and provide the text for summarization. Since the text contains line breaks, it should be wrapped with the templating method that escapes them. Perfect. Here is the JSON in the response. We can parse it with a simple edit object step like this, working with the JSON like a JavaScript object. Here is our structured response in the specified JSON format. The second approach is function calling. In the case of ChatGPT, this works for GPT 3.5 Turbo and higher. We add tool choice author and a tool, a function containing the response JSON schema. Let's check. The response format is slightly different, but here is our JSON. In this case, the structure is guaranteed. If you want to receive a different format like XML, then this requirement and the format itself must be specified directly in the prompt content. Response format won't work here, like this. Structured output is great, but what if you want your model to reason better, to handle complex logic, to stop blurting out answers too quickly? That's where chain of thought, or COT, comes in. What is it? COT is a technique where you explicitly ask the model to think step by step before answering. In a prompt, you say things like, think carefully before you answer. Solve this step by step. Show your reasoning first, then answer. And instead of just saying 42, the model will go, let's calculate the total amount. Then we compare that to the limit. Therefore, the answer is. This massively improves accuracy, especially for logical or multi-step problems. Now here is where it gets fun. Combine COT plus structured output. You tell the model, first reason through the problem, then return a clean JSON result. Why is this useful? You can show the user how the model thought through the problem. You can catch logical issues mid-process. It builds trust and gives you hooks to improve or debug your flows. You don't even need to show the full chain of thought to the user. You can store it in logs or use it internally for debugging. For example, we ask to solve a math problem and define the function for structured output of the reasoning steps. To ensure this, we specify it directly in the system message. We check and see. We get a separate array with the reasoning steps and the final answer. So, chain of thought plus structured output isn't just ask and get an answer. It's a structured reasoning pipeline with traceability, safety, and real-world logic. Let's get back to RAG and discuss something that's crucial but often overlooked: chunking. How do you split large documents into chunks for vector search? When you're just starting out, you might embed the whole thing at once. Quick, easy, and for small docs it works. But as your dataset grows, you run into trouble. Why? Because LLMs have a context limit. They can't read 100 pages at once. If you embed a huge document on go, you lose detail, nuance, and retrieval precision. So we need to split documents into chunks. A chunk is just a piece of text, but how you chunk determines what gets retrieved, how relevant the answers are, whether the module understands the context. There are three main approaches. First, by length. Just cut the text every 500-1000 characters, optionally with some overlap, say 100 characters. Fast and simple, good for short docs, but it might split ideas mid-sentence. Second, by structure. If your docs have headers, paragraphs, line breaks, use them as natural boundaries. This works great for FAQs, policies, guides. And the third, by meaning, the most advanced method. Use LLM to semantically split the text into coherent logical units, best for long or complex documents. Which one to use? Simple doc, use length. Well formatted, use structure. Complex or messy, use semantics and LLM. How to know your chunking is bad? The model says, no relevant results too often. Answers sound the same, no matter the question. Logic breaks. The start of the answer is there, but the end isn't. Let's see how to implement different chunking strategies in Directual. We have a structure called documents, and in it, an object with a long piece of text. We're going to chunk the text. Let's create a new table, chunks. It will have two fields, the chunk text and the link field, a reference to a parent document. In the document structure, we'll add a field type of array link. This will be an array of back references to chunks. Now let's build a scenario for chunking. For chunking by length or structure, we'll use a JavaScript expression. For semantic chunking, we'll use an LLM, in our case, ChatGPT. There will be an intermediate step. We'll generate a JSON with an array of chunk objects and then parse that array into individual chunk objects using the JSON step. So, by length, let's ask ChatGPT to generate a JavaScript Lodash expression tailored for Directual. It should convert the text into an array of chunks with a set length, say 100 words, and an overlap of 10. We paste the expression and replace the variables with the field references. Don't forget to wrap it in backticks, since it's a multi-line string. Also, for arrow functions and newer syntax, make sure to enable the latest JavaScript engine in the scenario settings. Looks good. Validation paused. To save into a JSON type field, don't forget to wrap the result in JSON stringify. We test the step and check the output object. Here is our intermediate JSON. We copy it and paste it into the parsing step, then configure it to parse the array into objects. Run the entire scenario through debug, and here are our resulting chunks. We see the overlap, but in some places the meaning breaks mid-thought. You can experiment with the chunk size and overlap for better results. The next step is embedding. We send the resulting array of chunk objects into a link scenario step and run vectorization there. We also use that same scenario to pass a reverse link to the parent document via a context variable. The second approach is structural chunking. Again, we ask ChatGPT to write an expression, But this time we split by paragraphs and include headings in the chunks. That means adding a condition: if the chunk is shorter than 7 words, likely a heading, merge it with the next one if it exists. Okay, we again replace the variables with the actual field. Run the scenario. Here are the chunks. Look solid already. Most likely, the result will look similar to the third approach, semantic splitting. We send a request and ask the model to return structured output, our JSON with an array of objects. Run it. Yes, here are the semantic chunks. The result is similar to the second approach. Note, when adding chunking, you'll need to update the whole app, so that the user sees both the individual chunks we injected into the prompt and the link to the parent document. Let's talk about one of the trickiest problems with LLMs: hallucinations. That's when the model responds confidently, fluently, but completely makes stuff up. We've seen examples already. But how do we deal with these at an advanced level? One very useful tool: logprobs, short for logarithmic probabilities. What are they? Every token the model generates has a probability score. The logprob tells us how confident the model is in generating that token. Here's how to use it. Let's say you ask the model, what's the warranty period? It says 3 years. You check the logprob of the token 3 and it's something like 0.01. That's a red flag. The model likely made it up. What can you do? If logprob is too low, don't show the answer. Ask the model to regenerate. Add a fallback like, not sure, but here's the closest I could find. Or pick the best answer from multiple generations based on token confidence. Let's check how it works in a Directual scenario. Let's create a data structure called logprobs demo. It will have 3 fields: request, response, and HTML. In the last field, we'll visualize the logprobs. We'll create an object with ID equals 1 and use it for all our testing. Let's add a new page and place a cards component with our object. Below the API endpoint, we'll add a synchronous scenario, so the UI updates with every object change. The scenario will have 2 steps. First, we'll make a request to the LLM where we specify the logprobs parameter as true. In the second step, we'll visualize the logprobs. We'll ask ChatGPT to generate HTML and CSS code that highlights high probability in green, medium in yellow, and low in red. Just a reminder, probability is value from 0 to 1. We take the logarithm of the probability, so it's always negative. The closer the log probability to the 0, the higher the actual probability. Alright, let's test it. For example, how many days are in the week? Okay, the model is confident it's 7. Everything works. We can visually see the probability of each token, word or part of a word. Now, if you're using structured output, logprobs become even more powerful. For example, you ask the model to return a JSON like answer 3 years. You check the confidence on 3 and decide whether to accept or reject the answer. With logprobs plus structured output, you can build robust logic like filtering out sketchy answers, asking follow-up questions, logging doubtful responses, giving your assistant a more human-like cautious tone. This gives you control instead of just blindly trusting whatever the LLM spits out. And finally, let's talk about local LLMs. Yes, you can run a language model on your own machine, server, or even a laptop. Why would you? No API restrictions. Total privacy, your data stays with you. No token limits or subscriptions, just your own hardware costs. Though fair warning, big models need serious hardware. A regular laptop probably won't cut it. Let's see how to set that up. Now I'll show you how to run the open source Chinese LLM Quan locally on your MacBook. On Windows, the process is almost the same with only minor differences. Even though the rest of the course is no code, here in the advanced part we'll do a bit of programming. Let's open the terminal and check if we have the required tools installed. Type the following commands one by one. Brew, a package manager for Mac, kind of like an apt on Ubuntu. Python 3 and pip3, Python and its package manager. Virtualenv allow us to create an isolated environment so we don't mess up with the system Python. If something is missing, no problem, just ask Quan how do I install, say brew, it will guide you. Now let's create a virtual environment for all dependencies using virtualenv. We'll name it quanenv. In the terminal you'll see a line like this. That means you're now inside the environment and any library you install will go into it without affecting your system Python. It's convenient and safe. Let's install all required libraries. Just copy the commands from the video description. Next we go to Hugging Face. It's like GitHub but for LLMs. Quan is available there. There is where we'll download it from. Go to the Access Tokens section and generate a new read-only token. We log in into Hugging Face in the terminal and enter the token. If it asks add token as Git credential, hit N. We just want to download the model, not push to Git. Now let's do our first test to check if everything works. Open Jupyter Notebook, a lightweight interactive environment where it's easy to write and run Python projects step by step. If it's not installed, just run pip install notebook. Create a new notebook or a py file, for example taskquanpy, and paste in this code. We'll link to the blog in the description, just copy it from there. What's happening here? We'll load the model and tokenizer, send the prompt and get a response from the model. Let's run it. On the first run, the model and tokenizer will be downloaded from the Hugging Face. This might take up to 10 minutes depending on your internet speed. After that, they are stored locally, no need to download again. This is a basic smoke test. We're just checking that the model runs and can generate text. Everything works, congratulations! We just ran Quan locally and got our first answer. Now let's build something actually useful. A local API that works just like ChatGPT's. Create a new file, paste this code, it mimics the OpenAI API, same request format, same response structure, and launch the server. The API is now running locally. In the console you'll see a message. That's normal warning. Flask is telling us the server is only meant for local development. It's single-threaded, no DDoS protection, no logging, but for testing and debugging that's more than enough. Now, to make this API available from the internet, including for using Directual, we'll expose the port using ngrok. Ngrok is a small utility that creates an external HTTPS tunnel for your local server. Install it via Brew or download it directly from their website. Login, copy your auth token and start ngrok on port 8000. Ngrok will generate an external address. Here it is. You can use this address in Directual in an HTTP request step. Let's test it right away. Add a request step, enter our API address, method completions, type post. Save the response to a field, enter the request body in JSON format, and increase the timeouts a bit. We are running an LLM on a laptop after all. Run the debug and wait for the response. Perfect, it worked. Here's the JSON response. Right now, we are using the Quan LLM running completely locally. And that's a wrap. Now you've got the full stack, not just to play with AI, but to build real AI agents and RAG systems that solve real-world problems. We've covered how LLM work, why RAG is essential, how vector search and embeddings function, how to structure reasoning with the chain of thought, how to use structured output, how to catch errors with logprobs, even how to run your own models locally. And the best part, you can do all of this without writing code, thanks to Directual. And hey, we've got a great community too. If you're stuck, ask. If you build something cool, share it. If you're just curious, come hang out. We are on Telegram, Discord, and YouTube. No bots, just helpful, friendly people. All the links are in the video description. See you around.